Welcome everyone. In today's presentation, we will be exploring a dataset that provides valuable insights into various factors related to customer transactions. We are looking at credit card fraud detection. This is a very interesting topic because it's a topic that we are more familiar with on a day-to-day aspect. We deal with a lot of financial data, we make a lot of transactions on a daily basis, and credit card fraud detection helps to identify whether these transactions could be fraudulent in nature. Maybe the card is being used by a person who is third party, who is not the legal owner, for example. And moving on to the agenda, we'll be discussing about who our members are, the introduction, problem statement, objective, literature review, data, methods, EDA, results and discussion, future study and limitations. Next slide, please. So here we can meet our team. We have Abrasha Ahmed. Then it's me, Muhammad Fahad Farhan. Then we have Po Yin. We have Yuan Xuan. And we have Tijan Rong. Next slide, please. All right, so I'll be discussing the introduction, problem statement, and the objective. All right, for the introduction, the dataset includes several features such as distance from home, the distance from last transaction, the median purchase price, repeat retailer status, chip and PIN usage, online order status, and a label indicating whether the transaction is flagged as fraud. This dataset offers a unique opportunity to understand the relationships between these features and the occurrence of fraudulent transactions. Next slide, please. Now we'll be moving on to the problem statement. The problem we aim to address with this dataset is the detection of fraudulent transactions based on various customer-related factors. Fraudulent activities pose significant risks to businesses, leading to financial losses and a huge damage to their reputation. Therefore, it is crucial for businesses to develop effective fraud detection systems by analyzing the provided dataset. We will be exploring the provided dataset and its correlations between the different features and the occurrence of fraudulent transactions. This analysis will help us to develop a predictive model that can identify when a transaction can be flagged as fraudulent accurately, helping businesses save on their costs and reduce financial harm. Now I'll be moving on to the objectives. As for the objectives, we are looking to explore the dataset containing customer transaction information and its associated features. We are also looking to analyze the dataset to identify potential patterns or trends that indicate fraudulent activity, which can be done through different deep learning models. We also plan to develop and evaluate the performance of the predictive model and measure its accuracy in terms of detecting fraudulent transactions, provide recommendations for businesses to enhance their fraud detection systems, and also contribute towards the prevention of large financial losses. This is a major reason why a lot of financial scams have taken place, and in order to solve these sorts of problems from occurring in the future, these models are improvised continuously to have the highest accuracy. With that, I'll be passing it on to Desmond. Thank you.
Hello everyone, my name is Desmond, or Tijan Rong, you can call me that, either one. So today I'm going to talk about literature review and data. Next. So as for literature review, Trevor Osagi, a manager and bank manager, was pleaded guilty to conspiracy to commit bank fraud involving stolen credit card information, and over $1.5 million in fraudulent purchases were made using more than 4,000 stolen credit card accounts. So what we can do to avoid this from happening is that we should always report lost or stolen cards immediately to a card issuer. And next, we should secure online transactions and be cautious of suspicious websites. And it is also recommended to use the strong, unique passwords for online accounts. And lastly, we should keep our cards secure and never share our cards information with any untrusted sources. Next. Search for data. We use a duplicated function to check if there are any duplicates in our data, and then we drop all the duplicated rows using the drop underscore duplicates function, and save the updated data to the data frame. Next, and the other way we removed outliers is that we first calculate the median for the first three columns, and then we calculate the threshold for our data, And if the data exceeds or below the threshold, which is like the 3 times of interquartile range or 3 times below it, then we'll replace the outliers with the median value, like all of them. And the other method we use to check for outliers is we check if there are any missing values. And since there aren't any missing values, we didn't remove any, or we didn't counter it. Yeah. Now I'll pass it on to Abrar.
So we'll talk about methods we use for cleaning. So first we've talked about outliers, as we said before, that we have used two ways, right? So one way was that we use median, and we use that to replace any values that were beyond the threshold on the lower end and the upper bound. So on both sides, if there was any value that was beyond that range, so we replaced it with a median. Another one was that we used standard deviation, right? So what we did is we set the standard deviation of the data set to a value of 2 from the mean. So if there's any value that is beyond that value of 2, that value will be classified as outlier, and then it will be removed from the data. And we also remove duplicated data by dropping them from the data set. And then we save the new data set as computed data set. Next, we'll pass on to Paul for explanatory data analysis.
So for our exploratory data analysis, these are the things that we did. The correlation matrix, where we single out the correlation of binary variables with fraud. We also did the histogram and bar charts for the variables, and then classify them as normal and fraud cases. And then we also found out the most appropriate machine learning model amongst the decision tree, random forest, and logistic regression.
Okay, now I will talk about methods for the model that we use. So first we use decision tree, right? So for the decision tree, we've split the data into two sets, the train set and the test set, right? And then we set it onto the train size of 75, which means that the data set was split into 75% for train and 25% for testing. And then we also stratified it. Stratification basically is just a way to handle imbalanced data, because since our data set has a lot of non-fraudulent cases and a few fraudulent cases, so we need to make sure that there's a balance between the two. So we use stratify to handle that situation. And then through the decision tree classifier, you trained the decision tree model, and then from that we have also printed out what our decision tree looks like, which is, as we can see right now, this is our entire decision tree. And next we have random forest. Random forest uses the concept of decision tree, but now we use it for many different smaller decision trees. Okay, so first we're gonna do the same thing for training and testing, but this time we're gonna do something called bootlegging. Bootlegging basically just means that we're gonna take the data set for our training, right? We're gonna split it into even smaller sets, and then we're gonna pass it into different decision trees, and then we're gonna pass certain features from our total feature set. We're not gonna use all the features, we're gonna use some of them, and then we're gonna train them individually, and we're gonna have many different decision trees. And what we're gonna do is, let's say we have a new data. The new data will go through, and then each of the decision tree is gonna give a outcome, which is either a 1 or a 0, right? And the majority, whatever the majority is, that's what's gonna be our answer. So if the majority says there is more ones than zeros, then it's fraud, and if it's more zeros than ones, then it's not. And this is just a way for us to show which feature was more important when deciding for our random forest. Lastly, we have logistic regression. Logistic regression uses a similar concept of regression, but slightly different in the sense that it calculates the probability of new data to be either 1 or 0, or either fraud or not fraud. The way it does that, so it will take the line on a graph, let's say for 1 for 0 and 1 for 1, right? And then it will create a line, a probability line, usually like an S curve, okay, where from the threshold of 0.5, which is the default threshold, any value that is above the value of 0.5 will be considered as a 1, and every value that is below the value of 0.5, which is, I'm talking about probability, by the way, this will be flagged as 0. And we're going to use the same concept here as well. But for this, we also need to do something called standardizing. Okay? Why do we need to do this? Because we need to fit all the features the data set for the features into zeros and ones. If we don't do that, then what's going to happen is we are not going to be able to fit the data set within that range. And then we will not be able to know whether is it actually 1 or 0 or not. So for that, we standardize it first, and then we fit it into our logistic regression classifier, and then we train our model. Now I'll pass on to Paul for results and discussion.
For the first part of the result discussion, we use correlation metrics. So here we can see the correlation between the various variables. We pick out variables that have a most of significant correlation with fraud, such as online orders at 0.44 and ratio to median purchase price at 0.36. We however find that one of these correlation is more useful than the other when we explore further. Okay, for online orders versus fraud, we find that despite almost all fraudsters use online transactions, this information is not very useful because many users also do the transactions online as well. So we find that preference for online orders, amongst others, can be seen as fraud technique. So information like this also presents a limitation in credit card fraud detection. Okay, for ratio to median purchase price was fraud. For this correlation, we find that almost only fraudsters purchase at more than 4 times the median purchase price. So this such information is very useful in detecting credit card fraud. Because banks have paid attention to unusually expensive purchases to sift out possible fraud. Okay, now we look at distance from home versus fraud. Okay, despite this correlation being very small with fraud, distance from home is actually a very useful metric because almost only fraudsters use their credit cards more than 100 units from home, as per the graph. So the fact that most normal users and fraudsters use the cards close to home, this fact may make it hard to detect fraudsters. We can easily use this kind of information as to our advantage. You can narrow down the search range for frauds if user suspects fraud, and if the address linked to the card was changed recently, you can use this info to search for fraudsters residing in the vicinity. Okay, we also did the confusion matrix for the decision tree model. This is our first machine learning model. We find that this model is right 99.5% of the time, making it very effective at predicting fraud. We obtain this value by looking at the true positive and true negative over the total data points. Okay, for the false model, we have a very similar result. The machine learning algorithm is right also about 99.4% of the time, making it very effective at predicting fraud. And lastly, for the logistic regression model, we find that the algorithm is only right 72.1%. So it's not as good as the random forest and decision tree models, but it's still reasonably effective at predicting fraud.
Now I'll pass it on to Yunshen for limitation and future study.
Now let's start with the limitation. So the first key is fraud techniques. So fraudsters continuously develop new strategy and technique to bypass detection system. So they have to adapt the changes in security measures and exploit vulnerabilities, making it challenging for detection system to keep up. So constantly monitoring and updating for fraud detection modeling is necessary to stay ahead of emerging fraud patterns. So second will be the data quality. The accuracy and completeness of the data used for fraud detection are crucial. So inaccurate or incomplete data can lead to false alarm or missed fraud cases. Additionally, data source may be limited and relevant data needed for fraud detection such as transaction details or customer behavior patterns may not be readily available. So last will be class imbalance. Credit card fraud is relatively rare compared to legitimate transaction. So this results in class imbalance in the data. So this can be bias the performance of fraud detection models as they may be more inclined to classify transaction as non-fraud to optimize the accuracy. Addressing the class imbalance through sampling techniques or algorithm adjustment is essential to ensure balanced detection performance. So next, I'll be talking about the future studies. So the first point will be real-time fraud detection. Developing real-time fraud detection system that can be monitor credit card transaction in real time and flag suspicious activity immediately is an important area for future research. This can be involve the use of stream processing frameworks and algorithms that can analyze and detect fraud pattern in real time, enabling timely interventions and prevention of fraud transactions. So the next will be advanced machine learning techniques. Future study can explore more advanced machine learning techniques such as method like gradient boosting or XGBoost or deep learning approach like neural networks to improve the performance of credit card prediction model, as this show promising result in various domains and may provide better accuracy and detection rates for credit card fraud. So lastly, we have incorporating additional data source. So to enhance the accuracy of fraud detection model, future study can consider integrating additional data source such as customer behavior patterns, geolocation data, and social network information. So by incorporating diverse data and models can capture more patterns and improve the ability to distinguish between the legitimate and fraud transaction. So that's all for me. Thank you.